Okay. All right. So last time where we stopped was on question 11, and let's do a couple more of these questions. In particular, let's move on to question 13. Can everybody see question 13? You can type in the chat. Yeah, you can see it. We got it. Okay. So yeah, that's exactly right, Jacob. So this would be where you would put question because you're kind of going back to a different issue. Um, but just really quickly, I'll say that, yeah, so the assessments are something that I open up, and like when we're going to do a quiz or, a midterm or something like that. And so I give you guys special information. So it's a different thing. So I would say don't even bother about the assessments right now. I'll let you know when we need to go there. Um, so so moving on, or moving back to where we were before. So question 13. So it's very similar to the other question that we answered, which was question 11, but it's a little bit different. So why don't you guys go ahead, and if you have any questions on question 13, you can ask. But go ahead and work on question 13, and then we'll discuss it. Okay. Ask. Um, who has an answer?
I do.
Okay. So do you want to type in the chat? Because I can't, there are like so many names that come up all the time when somebody says, I do. I don't know exactly who that is. So you could just type VOL for volunteer in the chat, and then I could see your name. Okay. So this is Jacob DeMonico. Okay. So Jacob, you want to explain to us what you did?
So I did two ways. I did the way you did last activity with the area of the trapezoid, and I also did just the standard area under the curve formula with the integral.
Okay. And like I said, you always want to be careful about that. The biggest mistake that people, if they get used to doing it, you kind of, you know, knee jerk go to that, and then people forget about the constant of integration, and they either just assume it's zero or they don't pay attention to the problem. So doing it my way is, doesn't require calculus, but just, heads up, I have no problem with you using it. I would, like I said, there are parts of this class where the intuition of the models as we discuss them, I will use calculus, and I'll teach a little bit of calculus to the class, um, but yeah, the constant of integration can always be tricky. So, so why don't you go ahead and type your answer in the chat for us? And Jacob came up with 71.5. And I know that you guys have the little icons where you can do like a thumbs up. And I don't know, actually, see, this is a good question for me. Um, I don't know, like, if I have to see where it is. But if you guys like agree with Jacob, so Kapil agrees. Does any? So I only have one person agreeing. Sebastian, Hannah, Nicole. Leave your thumb up for a minute, I guess. Does anybody disagree? I don't know if there's an icon for disagree. Okay. So no, nobody disagrees. Okay. Why don't we have Jacob go ahead and you can go ahead and do it in the chat and just kind of justify your calculation based on the equations. Okay, Jacob? Okay. So so um okay, so you're saying you put um x equals 3 into the equation and x equals 2 into the equation. And yeah, so I just want to point out that, and you can go ahead and do that. That's totally fine. There's no issue there. But like the very first thing that I would do, and just because I kind of get a little bit paranoid that I might make a mistake, is I would graph the equation. And for number 13, we can see that the y-intercept is going to be 84, and it's going to be a slope of -5. And so we can just draw a downward sloping line. And then we know we're going to be looking at the height of that function, right, at two different points. And so um, I'll be, it's kind of hard to move back and forth between the whiteboard and and another screen, but I will give a very simple illustration. And one of the things that some people get confused about on these questions, so this is my diagram. I'm guessing you guys can see it. So is that the same area that you were looking at, Jacob? Yeah. So so yeah, so we have to find um, the height of the function at these 2 points, and that's what Jacob said he did. He said he quote plugged in these values, which is another way of saying he evaluated the the height of this function, or he evaluated the value of the function at these two different points in the domain of the function. Okay, and that's because he wanted to get the distance for the two bases of this right trapezoid. Okay, all right. He goes ahead and he does that for the value is equal to 3. So we know that one of the sides of the trapezoid is 69. You want to give us your value for the other one, Jacob? Yeah, and then the other one is 74. So again, if you guys can see my crude diagram, we have this base has a length of 69. This one has a base of 74. And then what's next, Jacob? All right, I guess you're typing for us. Dun dun. There's suspense. Are you there? Okay. So the difference between the two x values is 1, so that's the height or the distance between the bases in the right trapezoid. So then the trapezoid equation becomes 69 plus 74 divided by 2 times 1, and um, Jacob. Okay, good job. Ignithium agrees with you. You justified it. We agree with you. Is there anybody that has any questions about that? It's pretty straightforward. Um, I do want to point one thing out to you guys, which is that that one of the things that we did is we provided not the only and not the best, but a commonly used estimate for what we'll later refer to in the class as a marginal change. So, for example, you might hear the terms marginal cost, which you will surely hear in this class, but you might have heard it before, or marginal benefit, or marginal productivity. And typically, when we're talking about that, we're talking about a slice of an area under the function. And the reason why I say this is a commonly used estimate because it's common for people to assume that when we change levels of production or the consumer changes their purchases of a good, they do it at just one unit at a time. Um, and in lots of cases, that makes sense. You buy two pairs of shoes or you buy three pairs of shoes, and you buy your next pair of shoes, you buy a fourth pair of shoes. So your change is you're going, one unit at a time as you increase your purchases. Or if it's an assembly line and they're producing something like cars, they don't produce a half a car, but they produce, one car, two cars, three cars. If they're at 100 cars, then they produce the 101st cars. So the 101st car. So that's a common estimate for a marginal change. But I want to warn you that in lots of cases, it doesn't really make sense um, to think about um, marginal changes as being a whole unit. And typically, um, even though we might fictionally entertain the idea that we're changing production a unit at a time, um, for marginal change to really have the meaning it's supposed to have, you want to have a small change, right? And one isn't necessarily small, right? So if you go from, one aircraft carrier to two aircraft carriers, you've doubled your number of aircraft carriers. That's not necessarily a small change within the meaning of what it means to have aircraft carriers. Likewise, it might be that you're changing your purchases of gasoline and you don't have to purchase, you know, gasoline in whole gallon increments. It's a continuous variable, which means you can purchase just a little bit more gas, right? Um, a quarter of a gallon or a tenth of a gallon. Um, so even though a lot of times when we mention marginal, we'll talk about, oh, this is what, would happen to the consumer if they purchased another unit. Um, Formally speaking, and in lots of contexts, that doesn't make sense. You should kind of, be on alert. Because like I said, ultimately, at the end of the day, what economists bring to the table is we make meaning out of the mathematics in our discipline for other people who aren't familiar with the math. So we have to be careful in our interpretations. Okay, so let's go ahead and move on and do another question that's different. We'll go ahead and do um, question 14. And this is a standard simultaneous equation type problem. Just note that this would be like finding the equilibrium point between demand and supply. And I'll give you guys a minute to work on this one, and then we'll go ahead and review it. Okay. Who's our next volunteer? You can type it in the chat. No. Oh, oh, oh. Okay. Marlena volunteered. So Sonica, the only thing I'd like to say is please remember just wait because we'll choose the volunteer and then we'll go ahead and we'll talk about the answer.
Sorry, I thought when you meant volunteer the answer, you meant like type it in the chat.
No, I
I'll
meant
remember that
chat
next
with
time.
me, work through it with me because it's supposed to be a learning exercise, right?
Yeah,
And
sorry about
so,
that.
no, it's not, it's a minor party foul. It's not going to get you kicked out.
Yeah,
Okay,
I'll remember that next time.
that's okay. So Marlena, can you give us your answer?
I got 81 over 7 or 11.57.
Okay, so you got the same thing. So do you want to just give us a couple of lines in your chat about like how you worked through this?
Should I type it into the chat?
Yeah,
Okay.
that's fine. Okay, yeah. So they're both equal to y. So you set them equal to each other, and then you solve for x. Maybe you just show us up a couple more lines just in case anybody happens to be confused. Um, it's always, uh, uh, yeah. Ooh, it's so exciting. It's almost there, right? Okay, and I think that's fine. So x is equal to 81 over 7, and let's see, 11.57. Yay, Marlena. So now, Marlena, just because we're just, like there, right? We can answer question 15 also. So, do you want to do that for us?
Uh, is it also 81 over 7?
Well, no. Okay, so like read question
Oh, the value of y. Okay.
right. Okay.
Okay.
You're like the equations are the same, but the question's
Yeah.
a little different.
Oh wait. Give me a second to do the math.
Sure, no problem.
Um, 26.14.
Okay. So let's luckily math is not done by committee. Um, but let's just see how many people agree. Um, you want to type what you said in the chat? Okay. All right. Does anybody disagree? No, no, nobody disagrees. Okay. So, all right. Well, and was it 26.148329, would it round to 26.15?
Let's see, I think the fraction I got was 26.142.
Oh, well, anyway, it's close.
Yeah, okay.
Yeah.
Hi, sorry to interrupt. Yeah, one of the first equation that you solved, it becomes like 26.14, but then the second one is 26.15. So I don't really know why the two answers are just a little bit different by like the one.
What do you mean the first? You mean like this one?
Yeah, so when you replace both like when you replace both x's with the
Oh, yeah, see, it's rounding error that we're dealing with.
just like a
And
very minor discrepancy.
yeah, and I'm sure if we were like really precise, that we probably would end up agreeing with this. I will tell you, there's a little bit of rounding error, and sometimes people get sort of freaked out about that on ignithium, but um, um, in general, it's not a problem. And even ultimately, when we're talking about like scores, right? If you're just off a tiny bit, it's not a big deal. But you don't want to be at all sloppy. You know, I had one student a couple of semesters ago who was super careful. And she actually did everything to 4-digit precision. She showed me all her work. And she said that she never ended up with an error that way on ignithium. So, sometimes we're dealing with multiple calculations and, multiple situations. And sometimes it's important to be precise. But yeah, I mean, if it's really close, then you shouldn't have a problem. But
Okay.
just don't be sloppy. I mean, you get some people that they'll just round 11.57 to 11 or to 12 or something like. Don't ever do that. If you do that, then you'll just compound the rounding error and you'll end up way off. So yeah, and then you'll end up not getting any credit. So be careful, but don't be paranoid.
Okay.
Okay. Um, okay. So, but everything should be close. So I don't know if there's anybody has any questions or wants to chat, but um, I noticed there are a couple of comments, but I'm assuming everything's okay. Um, so it's 8:18, and we would normally have like a 10-minute break, but I'm gonna go ahead and talk about. mm, let's see. Oh, um, so number 16 is a good question, and so so let's go ahead and you guys can write down number 16 or take a screenshot, okay? And I'll actually reveal the answer, okay? So you guys can work on that and we'll pick it up next Tuesday. And that's where we'll end the session for today. Does anybody have any questions for me about anything?